In this video, we will learn how to balance redox equations step by step. Redox reactions are everywhere in batteries, metabolism, and even rusting. But balancing them can be tricky if you don't follow a clear method. Today, I'll show you an easy way to do it, whether the reaction happens in acidic or basic medium. By the end, you'll be able to balance any redox reaction with confidence. I've written here the steps that you need to follow when balancing a redox equation. So I'll start step by step. So as mentioned, divide the redox equation into reduction and oxidation half equations. So here's the given redox equation. So I'm gonna split it. MnO4 minus gives manganese ion, Mn2 plus, and I minus gives I2. That is step 1. Step 2, balance atoms other than hydrogen and oxygen. So any atom that you have but not hydrogen and oxygen, by adding coefficient, and the coefficient is a number that you write to the left side of the formula. So let's start here. 1 manganese and 1 manganese. So this Mn is already balanced. Leave it. 1 I and 2 I atoms. So we balance I by adding a coefficient on the reactant side. Now I have 2 I atoms on both sides. Next step, balance O by adding H2O on the side that needs H2O. So let's first count the oxygen. On this side, there are no oxygen. On this side, you have 4 oxygens. So you balance on the side that is lacking of oxygen. So here is the side where I don't have oxygen. So in order to balance the 4 atoms of O, we don't add coefficients, we add H2O. So I'm going to add over here 4 H2O. Now this equation over here doesn't need balancing of O, it doesn't have O. Now after balancing oxygen, you now move to balancing hydrogen. So you balance H by adding H plus on the side with less hydrogens. And you have to follow these steps in this order. You should not mix those steps. So now I'm gonna count how many hydrogens I have. On this side, we have 4 times 2, 8 hydrogen atoms. And on this side over here, no hydrogen atoms. So you balance hydrogen by adding H plus on the side that needs more hydrogens. So here we need 8 H plus. Again, this equation over here doesn't need balancing of hydrogen. It doesn't have hydrogen atoms. The next step now is to count the charge and balance the charge by adding electrons. Keep that in mind. You add electron on the side that have the higher charge. Let's now count the charges. Over here I have a minus and I have 8 pluses. So 1 minus and 8 pluses, that would be equal to 7 plus as a charge. Whereas on the other side, I only have 2 plus. So you add electrons to the higher side of charge. So the 7 plus needs 5 electrons in order to become 2 plus. So again, you look on the side that is having higher charge. To that side, you add electrons until you make both sides equal. So here having 7 plus, we're gonna add to the reactant side 5 electrons. And now we're done with this first half equation, we call it. Because the electrons are added with the reactants, this is a reduction half equation where electrons are gained. Now, for the next one, we need to balance the charges. I have two minuses. 2 times 1 minus, that makes it 2 minus on this side. And on this side, there are no charge. It is neutral, 0. So this is the higher side. So you need to add 2 electrons on the higher side to make both sides equal. So I'm going to add over here 2 electrons. Now, because the electrons are written to the product side, this half equation is considered an oxidation equation where electrons are lost. Now, after doing this step, now you need to multiply the half equations whenever you need by the greatest common factor to have the two equations equal amount of electrons. Remember that the number of electrons transferred should be the same. The number of electrons lost should be equal to the number of electrons gained. Since here I have 5 electrons and here I have 2 electrons, we will multiply this half equation by 5 and this half equation by 2. Like this, we will have 10 electrons gained versus 10 electrons lost. And now we write both equations, we add them together. So, first of all, 2 multiplied by 5, that is 10 electrons, and 2 MnO4 minus, and 2 by 8, that is 16H plus. Also, don't forget to add what's on this side as well, because we are adding both half equations. So 5 multiplied by 2I minus, that is 10 iodide ions. Now, 2 Mn2 plus and 2 by 4, that is 8 H2O, 5 by I2 and 5 by 2. So plus 5 I2 and 10 electrons. Now, after adding both half equations, cancel out the substances that are common on both sides. So here we have 10 electrons, 10 electrons, they cancel out. And that's it. So I'm going to copy it again. Fully balanced in acidic medium. As you can see, we have H plus. So that makes this redox equation in acidic medium. H2O and 5I2. Now, what if we have a question to balance redox equation, but the medium is basic? So basically, we are going to follow exactly the same step, and then we add 2 additional steps, which I wrote here in red at the end. So as I mentioned, first, you split the given redox equation into 2 halves. So the first one is MnO4 minus, giving MnO2. And the second one, SO3 2 minus, giving SO4 2 minus. So let's first begin. I will list again the steps. So you balance all the atoms other than hydrogen and oxygen by adding a coefficient. And here I have 1 Mn and 1 Mn already balanced. Then You start balancing the oxygen by adding H2O as much as needed on the side that is lacking O. So here I have 4O versus 2O. So this is the side that is missing out 2 oxygen. So you add 2 H2O. As I mentioned, you balance O by adding H2O. And here we had 4O, while here we had 2. So we need 2 more oxygen atoms. The next step, you balance hydrogen atoms by adding H plus, of course, to the side that is lacking H plus. So here now I have 2 times 2, I have here 4 hydrogen atoms. So here's the side missing hydrogen, so you add 4 H plus. So you balance H by adding H plus. You balance O by adding H2O. You balance H by adding H plus. After you finish this step, you reach the step where you have to balance the charges. In order to do that, you need to count the charges on each side. Here I have 1 minus and I have 4 pluses. That is equal to 3 plus on this side. Whereas on this side, there are no charge, means that it is 0. So here is the higher side. When you are balancing the charge, you look at the side with higher charge and you add to it as much as needed electrons. So here I have 3 plus. I want the 3 to drop to 0. So I am going to add 3 electrons. Since the electrons are added to the reactant side, this is considered a reduction half equation, electrons gained. Now let's move to the other half of this redox. SO3 2 minus to SO4 2 minus. Again, you first balance the atoms, not H and not O. So here I have S, 1 on each side, so it is balanced. Then I move on. You balance oxygen by adding H2O on the side that needs more O. So here I have 3O, while here I have 4O. So I'm gonna need 1 more H2O to make it 3 and 1, 4. Next, you count the H and you balance H plus. You balance H by adding H plus. So here I have 2 hydrogens. So I need to add 2 H pluses on this side. Now the last step is to count the charges. I have a 2 minus on this side. And on this side, we have a 2 minus and 2 plus. So that means we have a 0 charge, no charge. It is neutral. So the higher side is this one. So I need to lower it to become equal to 2 minus. So I'm gonna add 2 electrons on this side. As I mentioned, you add electrons, you balance the charges by adding electrons on the side with higher charge. Now, the next step, you look here, you have 3 electrons versus 2 electrons in this oxidation half equations where electrons are lost. So since here there's 3 and here there's 2, we decide to multiply the oxidation by 3 and the reduction by 2. And we add them out. So 2MnO4 minus, 8H plus, 6 electrons, 3SO3, and 3H2O. So I'm going to write all these before the arrow. So 2MnO4 minus 8H plus 6 electrons, 3SO3 2 minus, and 3H2O. Remember that in this example I am doing it in basic medium, so the steps are exactly the same. When we reach the last part, you will see the difference. Now again, 2MnO2, 4H2O, 3SO4, 6H plus, and 4 electrons. So I'm gonna write that down. 2MnO2, 4H2O, 3SO4 2 minus, 6H plus, and 6 electrons. Now, before we move on, we cancel out the substances that are common. So here I have 4H2O and here I have 3H2O. So they cancel out and 1 H2O remains. And I have 6H plus and 8H plus, 2 remains. So I'm going to write it out again. 2MnO4 minus, and as I said, 2H plus remains, and 3SO3 2 minus. Now the H2O cancels out and 1 remains on this side. 2MnO2 and 1 H2O and 3SO4 2 minus. The 6H plus and the 6 electrons are cancelled out. Now, remember, I'm doing an example of basic medium. Now, when we are done, we count how many H plus we have on this equation. And you add OH minus to both sides of the equation as much as it has H plus. What do I mean by this? Here in this equation, I have 2H plus on this side. So we decide to add to both sides 2OH minus and 2OH minus. Now, why I need to add OH minus on both sides? Because I don't want to ruin the balancing that I did. And why I added exactly 2? Because I have 2H plus. So if you have 4H plus, you will add 4OH minus on each side. Now, since you have 2H plus, you're going to add 2OH minus on each side. Now, remember, here's the trick. Every 1H plus added to 1 OH minus, the plus and the minus, they cancel out. And this becomes H2O, a molecule of water. H, another H, that makes it H2O. So what you're going to do over here is write the equation again, rewrite the equation again, but instead of writing 2H plus and 2H2O, you're going to write instead 2H2O. So 2MnO4 minus plus 2 molecules of water plus 3SO3 2 minus, giving 2MnO2 and 1H2O and 3SO4 2 minus and 2OH minus. Again, if you have any common substances on each side, you cancel them out. So here 2H2O and here H2O. I'm just going to cancel this one and keep 1 H2O. So the final answer is 2MnO4 plus H2O plus 3SO3 2 minus, giving 2MnO2, 3SO4 2 minus, and 2 hydroxide ions. The presence of hydroxide ions on the equation indicates that this equation is indeed in the basic medium. Let me give you some more common examples just for the practice. So again, let's do a balancing in acidic medium. So first, you split the equation into two halves, one oxidation and one reduction. So dichromate ion Cr2O7 giving chromium ion Cr3 plus. So again, I'm going to keep the steps showing. We divided the redox equation. So that's the first half, and the second half is this one. Now, balance atoms, not H, not O, by adding coefficients. So here I have 2 Cr with 1 Cr. So I am going to add 2 on the side. I added a coefficient. 2 is a coefficient. Next, balance O by adding H2O where you need. So on this side, I have 7 oxygen atoms. So I am going to add 7 H2O on this side. Next, balance H by adding H plus on the lower side with H. So let's count again. I have 14, 7 times 2, 14 hydrogen atoms versus nothing on this side. So over here, I am going to add 14 H plus because I balanced the H by adding H pluses. Now we count the charge in order to balance it by adding electrons on the side of higher charge. So let's focus. 2 minus and 14 pluses. 2 minus and 14 pluses. That's a total of 12 plus charge on the reactants side versus 2 times 3, 6 plus on the products side. Now the side with higher charge is this one. So I'm gonna add electrons to it to drop the 12 plus to 6 plus. So we add 6 electrons because 12 plus and 6 minuses makes it 6 plus. And that is the first half reduction equation. Electrons are gained. They're written on this side. The second step, which is the other half of the equation. S2O3, 2 minus, giving S4O6, 2 minus. Again, balance atoms other than hydrogen and oxygen by adding a coefficient. I have 4s versus 2s. So I'm going to add 2 on this side like this. I'll get 4s. 2 times 2 is 4. Now, let's now count the oxygen. 2 times 3, that is 6. And already here, I have 6. So there is no need to add H2O. And since both sides don't have H plus hydrogen, so no need to add H plus. Now let's count the charge. I have 2 times 2 minus, that makes it a 4 minus versus 2 minus. This is the higher side, so we add to this one 2 more electrons to make it equal. Now, after having the two, this is an oxidation half equation because electrons are lost. Now here I have 6 and here I have 2 electrons lost. So we are going to multiply the oxidation only by 3 to make it 6 electrons lost and 6 electrons gained. And we add the two equations together. So Cr2O7, 2 minus, and 14H plus, and 6 electrons and 6S2O3 2 minus, giving 2Cr3 plus 7H2O 3S4O6 2 minus, and 6 electrons. Now it's the time to cancel out the common particles. And here's the final answer. In acidic medium. I'll give one more example of basic medium. H2O and 3 SO4O6 2 minus. Last example to do. Basic medium. Now this is a bit challenging because I only have one reactant. Even if you have one reactant, one half equation you will say ClO changed to Cl minus, and another half equation you'll write ClO changed to ClO3 minus. That's it. So now we start balancing atoms other than hydrogen and oxygen. I have one Cl, balanced. I have one O versus nothing, so I add one H2O on this side. Now having two H's, so I need to add two H pluses to make H equal on both sides. And now we reach the time to count the charges. 2 plus and 1 minus makes it 1 plus. 2 plus and 1 minus. Now, here I only have 1 minus. So the reactant side is the side with higher charge. If I added 1 electron, I'm gonna reach neutral. I don't want to go to neutral, I want to drop to -1. So we need to add 2 electrons on this side. And here you go. These are 2 electrons. And you're done with the first reduction half equation. The next one, ClO minus, ClO3 minus. 1 Cl, 1 Cl, balanced. 3O, 1O. So I'm gonna need two more H2O molecules to make it 3 on each side. By adding H2O, we now have 2 times 2, 4 hydrogens. So I'm gonna add 4 H plus on this side. Now it's time to count the charge. I have 1 minus versus 4 plus and 1 minus, that is 3 plus. This is the side over here with higher charge. You need to drop the 3 to -1. So if I added only 3 electrons, I'm gonna drop it to 0. But I needed to -1. So I'm going to add on this side 4 electrons. And now we're done writing the half oxidation reaction, which involves loss of electrons. Now, 2 and 4, we need to make the electrons transferred consistent and equal on both sides. So I am going to multiply the reduction by 2 in order to have 4 electrons gained versus 4 electrons lost. And now we add the 2 equations. 2 times all the sides. So 2 ClO minus from the reduction and 4 H plus from the reduction and 4 electrons from the reduction, plus this ClO minus and this H2O. So ClO minus and 2 H2O. These 2 particles, we are going to add them up in our next step. So now 2Cl minus and 2H2O and ClO3 minus and 4H plus and 4 electrons. Now we cancel out the common particles. So 4 electrons, 4 electrons, 4H pluses, 4H pluses, 2ClO minus and 1ClO minus. So that makes it 3ClO minus and H2O cancels out, giving 2Cl minus and ClO3 negative. This is already in basic medium because these substances are considered as Lewis bases. I hope that this video is clear to you on how to balance redox equations in basic and acidic medium. Make sure that you follow these steps when doing the balancing, and make sure not to do a step, not to mix the steps. So don't balance H before balancing oxygen. Never balance the charge before you're done if you're not done yet with balancing the atoms. Thank you for listening.